Hello, dear friends. In this video, I'm going to talk about the Tower of Hanoi problem. The Tower of Hanoi problem is a classical puzzle in computer science and mathematics. The goal here is to move a tower of disks from one peg, or you may say rod, to another. But we should be careful on a few specific rules. Okay, we are talking about the tower of Hanoi problem. Okay, and as I said, we need to be careful on a few specific rules. The first rule is only one disk can be moved at a time. Okay, only one disk can move at a time. Second rule, a larger disk cannot be placed on the top of a smaller disk. Larger disk cannot be placed on top of a smaller disk. Okay, cannot be placed on a smaller disk or on top of a smaller disk. And we have one more rule. All disks must be moved from the starting peg to the target peg, typically with the help of another peg. We are calling it auxiliary peg. Okay, all disks must be moved. All disks must be moved from starting peg to target peg. Okay, and with the help of an auxiliary peg. With the help of an auxiliary peg. So here, as you see, we have 3 pegs, and let me show you how we are applying these rules. With the pegs, assume that these are our pegs. So this is our starting peg, this is our target peg, and this is our auxiliary peg. And we have disks on starting peg. Assume that we have 3 disks. Okay, then we have 3 disks here, and we want to move all these disks from starting peg to the target peg. At the end of our solution, we will have disks here in this order. And when we are doing that, we should apply rule 1, rule 2, and rule 3. Okay, and when we are applying these rules, we will need an auxiliary peg, let's say temporary peg. Okay, and we will use this peg while we are moving our disks from starting peg to target peg by applying our rules. Okay, and here let me give you an example. Of course, we'll apply the rules and we will move our disks from starting peg to target peg. And let me give you an example. Let's say that we have starting pack, auxiliary pack, and target pack. Okay, let's call this. We are going to this is starting pack. This is auxiliary pack, and this is target pack. And assume that we have 3 disks here. Disk 3, disk 2, and disk 1. So the sizes are different. Okay, 3 is larger than all. Because of that, it's at the bottom. Then 2 is smaller than 3 but larger than 1, so that's why 2 is in the middle position, and 1 is smaller than all others, so that's why it's at the top. And we are going to move all these disks, I mean disk 1, 2, and 3, to our target pack, okay, by applying the rules. Let's remember the rules again. One disk can be moved at a time. A larger disk cannot be placed on top of a smaller disk, and all disks must be moved from starting pack to target pack. Okay, these are our rules. So in this situation, our first move can be this. I can move disk 1. Let's say that, let me give names to our packs. Let's say that this is our starting pack A, this is our auxiliary pack B, and this is our target pack C. So I'm going to move all this from A to C, okay, at the end. Now, my first step can be this. I can move disk 1 from A to C. This can be moved from A to C. So disk 1 will come here. Okay, so it will be moved from here to here. Then I will move disk 2 to our auxiliary pack. Disk 2 is here, so it will be moved from A to B. Then I will take disk 1 on top of 2 because it's smaller than 2, and I will let my target pack empty. So this one will be moved from C to B, and it will come here. So I still did not break the rules, okay? And I'm working on transferring the disk from A to C at the end. So here, my target is empty, and the larger disk is here, so I can take 3 and move it to my target pack. So 3 will come here. And this is my situation. So 3 is located in its right place. Okay. So what left? 1 and 2. So here I can take 1 from B and move it to A. Okay. So 1 will come here. And now I can move 2 from B to C. This will be moved from B to C. Okay. And then 1 left. So I can move 1 to C, from A to C. So 1 will come here. Therefore, I can say that I finished the transfer, and all disks are placed on target pack, which is called C. I applied the rules. I didn't break any rule, and now the larger disk is at the bottom, and 2 is smaller than 3 and larger than 1. It's in the middle position, and 1 is smaller than all others, and it's on the top position. So without breaking the rules, without playing the rules, I moved the disk from A to C. And this is successful transfer of the disks. Okay. Here, how we can write C program to solve this problem. Now let's talk about that. Of course, we'll apply the rules and we will produce a solution by using recursive function. We'll produce a solution by using recursive function. Let's talk about that. Now, let me move a little bit down. Okay, here, let me write the full code here because I'm going to trace it and I will explain how this code will run on this page, so it will be easier for you to understand. Let me start with include stdio.h. And here I need to write my recursive function, so I can say void Hanoi towers. So we have arguments here. Okay, this will be my recursive function, and here I will have my main function. I want to write that one as well. Void main. Okay. In the main, first of all, I'm going to read how many disks we have because we may have any number of disks. In the example I discussed today, we had 3 disks, okay, but it can be 4, 5, or more, or less, okay. So we are going to produce the solution for any number of disks, okay. Therefore, first of all, I will declare n, and I will ask user to enter n. Enter n. And I will read it, scanf n. Okay. After I know the n, I'm going to call my recursive function, Hanoi towers. Okay. I will have parameters here, and I will terminate my main function. It starts at ends here. Okay, now why I did it? Because I want to talk about the parameters that we are going to use here. Okay, the first one, of course, will be the number of disks. So I'm saying integer n. Okay, this is number of disks. Here, when I call the function, the number of disks is n, so I can say n as a first parameter. Then here we'll have 3 pegs, okay? Three pegs. So let's call this one A, this one B, and this one C. So in this situation, A is starting peg, C is target peg, and B is our auxiliary peg. Okay. Therefore, when I call the function, okay, I am going to mention these pegs, and also here in the function definition, I need to mention them. Let's say that character from, character to, and I have one more. Let's say, let's write it here. Let's move this one a little bit right. I need character auxiliary. Okay, let me draw my pegs here. A, B, and C. And here I will say A, B, sorry, C, and B. Why I said this? Because the second parameter here, it's from, I mean from to. So it will move disks from to, and this is auxiliary. So here it will move this from A to C, from A to C, and auxiliary is B, and auxiliary is here. That's why I said ACB here, okay? Okay. Then what happens here? It will, from at the beginning, from is A, to is C, and auxiliary is B, okay, at the beginning. So first of all, I am checking if n is equal to 1. This is my termination point. I'm working on recursive functions. So as I told you in our previous lectures, if you are going to write recursive function, first of all, you need to decide what is your termination point or base case, or let's say termination point, base case, or the final step, or where to stop. You can call it anything, but we need to decide where to terminate. And here, termination is when we have one disk, single disk. So if n is 1, we have single disk left. So here, I'm saying that printf move disk 1 from this to this. What are they? From this to this. So here I need to say this, I mean from, and to. This is from and to. Okay. And then I will return. I will terminate this function. So here I'm saying that disk 1, because only disk 1 left, or actually the first disk is left. This is the smaller disk, and that smaller disk left. So here I'm moving it from to 2. I'm using actually variables here because I don't know where the disk 1 is at that moment. Okay, and then I'm going to call the function itself. Hanoi Towers. I will call it, but here I need to use n-1. N-1 because the here n-1 because let me tell you in this way. I'm going to move top n-1 disks from A to B using C. C will be auxiliary here. Okay, and therefore I'm saying n-1 from auxiliary to. So when I call this function, in the first call, when I call here, okay, let me write from to and auxiliary parameters. When I call this one first, from is A, to is C, auxiliary is B. But if I enter here and n is not 1, so it will call Hanoi Towers function. It will call itself, but from will be from, in the second call. This is the first call. In the second call, from to an auxiliary. From will be from, so from will be A. Auxiliary, which is B here, will be my to, because the second let's say parameter is to. So I'm saying that auxiliary is to the value of 2 here. So my auxiliary will be C. Sorry, 2 will be my auxiliary, which is B. Okay, 2 will be 2 in this call. 2 will be the auxiliary, which is B. Okay, and in this call, 2 will be used as auxiliary. So 2 is C, and auxiliary will be C. Okay, and what happens here? In the first part, after in the first part, from is A, I'm going to move from A to C by using auxiliary B, and then I'm going to move top and minus 1 disks from A to B. So from A to B. Okay, and then auxiliary will be used C. This is the idea here. And then here, let me show you this. Let's say that we have 3 disks here. This is 3, 2, and 1. Okay, N is 3. I'm calling it with ACB. Then it comes here. N is not 1, so it will call the function itself. So it will call it with n minus 1. So in this call, n will be 2, and it will move disks from A to B by using C as an auxiliary. Okay, and for n2, it will call itself one more time. So we have another from, we have another to, and we have another auxiliary. Okay, this is the nature of recursive call. This is the nature of recursive call. It can come to a little bit complicated, but when you trace this, let's say, recursive function, you can easily understand. And I gave you the example before, so you can check it as well. And here, n will be 1. Okay, and what happens here? In this, when we are using n with n2 and we call n1, so n1 will be moving the disk from front to 2. Okay, and terminate the recursive function here, and then it goes back, and then it will go back from here. But it's not finished for n when n is equal to 2, because when I have this function call, I need to say printf move disk this from this to this. Okay, let's say /n. This will be n, disk n. Okay, will be moved from, this is this 2, will be moved from to 2, according to this code. Okay, and then of course it's not finished. I need to call Hanoi Towers function one more time here. Hanoi Towers n minus 1, but here auxiliary to and from. And here auxiliary, this will be this, okay, will be from here. To will be to, and from will be my target. And I'm calling the function itself one more time, okay? And this is the solution of Hanoi Towers. Now let me let me write this code in Visual Studio, and we can trace the code, or let's say that apply the output on an example. Then we can check if everything works correctly, so you can understand the things more easier. So I'm going to Visual Studio, and here let me write the same code here. Towers, Hanoi Towers, I have integer n, character from, character to, and character auxiliary. This will be my function. If n is equal to 1, then I'm going to say printf move. This is the moment of disk 1 from this to this. And what are they? From is from, to is to. And I will return. Okay, and then I will call Hanoi Tower, sorry, Hanoi Tower with n minus 1 from auxiliary and 2. And then let me copy from here. Okay, I will move disk. I don't know the disk here, so I will say %d, and I will get n. And from 2 again. And here I will call Hanoi Tower one more time for n minus 1, but here I will say from auxiliary to 2 and use from as auxiliary. Okay, by playing with the parameters, I did it. And here I will write my main and enter the number of disks you have, and scanf %d for n, and I will call the function with n. I will say a for from, b to 2, c to 2, and b will be auxiliary. Okay, and finish the function. So let's execute the code. Let's say that I will have 3 disks, and this is the solution. So here, what happens? Let me take this part and apply it here. So I can copy it. This is the solution it produced. Okay. Now let's try it and see what's happening here. So I have 3 pegs. This is A, this is B, and this is C. This is my starting, and this is my target, and this is my auxiliary. And I have 3 disks. This is 3, this is 2, and this is 1. So it says that disk 1 from A to C. Disk 1 from A to C. I will take it to here. This is 1. This will be moved from here to here. Okay. Okay, let's move it to here. Then 2 will come here. Then disk 1 from C to B, disk 1 from C to B. Okay, disk 1 will come here. This is 1. Okay, then disk 3 from A to C. From A to C, disk 3 will come here. And from B to A, I'm going to move disk 1 from B to A. So disk 1 will go back here. Then disk 2 from B to C, disk 2 from B to C. This is disk 2. And the final one, disk 1 from A to C. Disk 1 from A to C. So without breaking the rules, we transferred our disks from A to C. And here we applied the rules and we used recursive function to produce a solution. A solution means steps of moving disks from A to C without breaking the rules. Okay, friends, I want to use this function and implement it one more time, okay? Because I want to understand how this recursive is working. Here, assume that our n is 3. So we have 3 pegs, okay? We have 3 pegs. This is A, this is B, this is C, this is starting peg, this is target peg, and this is our auxiliary peg. And I have 3 disks, okay, on starting peg. Okay, therefore I will call this function with n3. So when I call this function with n3, I mean when I call here, let me show it like this. When I call Hanoi Tower function with 3, okay, this is from is A, 2 is B, and sorry, 2 is C, and auxiliary is B. This is my first call. In the first call, n is not equal to 1. Therefore, it will make another call of this function. So I'm here, okay? I'm here, but I have another call. So I'm calling another function. So here it will call another function, Hanoi Tower. But here n will be 2 because it says n minus 1. This will be 2. And from is from, it's A. Auxiliary, which is B here, will be the second parameter. So it will be my 2 here, okay, because I'm calling itself. And in the main, in this function, it's the first one is from, the second one is 2, and auxiliary is the last one. So I'm calling the same function. From is from. The auxiliary, which is B here, will be my 2. That's why I said B here. And then 2 will be my auxiliary here. So it will be C. Okay. Okay. When I call the same function again, it starts over. So what happens if it checks if n is equal to 1? N is equal to 1? No. So it comes here and then calls itself one more time. Hanoi Tower, n minus 1, n minus 1 is 1, so it will cut with 1. But from is from. It's still A. Auxiliary is to here. What is auxiliary? It's C. It's C here. From to auxiliary. From to auxiliary. So here, from is from. When I call it auxiliary, which is C, will be my to. And then my to, which is B, will be my auxiliary. Okay, when I call this function with N1, then it starts over here. This is another function because this is the same function is copied in the memory and executed as a separate function. So here n is equal to 1. Yes, n is equal to 1. So if n is equal to 1, it will say move disk. Here, when I do this on the black screen, it will say that move disk 1. Move disk 1 from this to this. Disk 1 move disk 1 from what? From to 2. What is from? Sorry, this should be FTA. From is A to 2 is C. Okay, it will be displayed here. What is the disk 1? Where is disk 1? It is really on A. So it says that move this one, move disk 1 from A to C. This is what it says. So let's do it. Let's do it. Let's do it. Then 1 will be here. Okay. Okay. This function will be terminated, isn't it? This will be terminated because we have return here. Then it will go back to this one. And here we have printf. It says move disk from to. Okay, move disk what? N. What is N? It's 2. It will tell me that move 2 from this, from to 2. What is from? A. What is to? B. So disk 2 will be moved from A to B. Disk 2 will be moved from A to B. Okay? Okay. Okay. Now, I am here. So I'm calling the same function again. Hanoi tower. N-1, it's 2. Auxiliary. Okay, what is auxiliary here? Auxiliary is C. Okay, I am calling the function itself. So let me show it here. Here I am calling the same function. I mean itself, Hanoi tower. And N-1, I have N is 2, so N-1 is 1. And here I have from to an auxiliary. So it says that aux is my from here. So what is aux? It's C. So it will say C. What is to? To is 2. It's B. What is from? From is here A and my auxiliary here. Okay. And when I call this function, it starts over. So it will come here. N is equal to 1. Yes, n is equal to 1. So move disk 1 from to 2. Okay, move disk 1 from what is from? C. What is 2? It's B, from C to B. So disk 1 will be moved from C to B. Okay, so 1 will come here. Okay. Then it will be terminated and it goes back to here. When it comes to this, so this function is finished. Okay, it's finished. And then when it is finished, here it will go back to the caller. So when I come here, Hanoi Tower N3, so I will display this message because I am here on this statement. So printf move disk this from move disk this from this to this. So what we have here, and now I am here, move disk n. What is n? It's 3. Move 3 from to. What is from? From this to this auxiliary this. Okay, from is A, to is C. So move 3 from A to C. Okay, I am moving 3 from A to C. Now 3 is here. Okay. Then I am calling itself one more time with n minus 1. So I am calling Hanoi Tower with 2. Okay. And we have from to an auxiliary here. What is from? From is coming from, what is from? It comes, you see, it's auxiliary. Auxiliary is B, so it will be B. And what is 2? 2 is 2, it's C. What is from? From is A, so this will be A. Okay. Then I am at the beginning. N is equal to 1. No, it's not equal to 1. So I am calling this Hanoi Tower. So this calls Hanoi Tower. N is n minus 1. So it was 2. So it is 1. And here we have from to an auxiliary. And here from is from. What is from? It's P. To here auxiliary will be my 2. So what is my auxiliary? It's A. And 2 is my auxiliary, so it's C. So when we have this, n is 1, I'm starting from here. N is equal to 1, okay? N is equal to 1. And since n is equal to 1, move this from to 2. Okay. Move 1 from is B, 2 is A. So 1 will be moved from B to A. So 1 will be moved from B to A. It will be here. Okay. Okay. Then it will return back to the caller. It will stop and returns back to the caller. So when it comes here, it will display a message, printf, move disk n from to 2. Okay, what is n? N is 2 here. So move 2 from, what is from? B to 2. What is 2? Is C. Okay, so 2 will be moved from B to C. And 2 will come here. Okay. Okay. And then it will call itself again. Hanoi Tower and minus 1, which is 2. Sorry, let me write it here. It will call itself to call itself Hanoi Tower. N-1, n is 2, n-1 is 1. We have from to 2 and auxiliary. What are they? Here, auxiliary is my from. What is auxiliary? It's A. 2 is 2. What is my 2? It's C. And what is my auxiliary? It is from. So what is from? B. So when I call it, n is 1. So when n is 1, it will execute this part. So here, this 1 will be moved from to 2. Move this 1 from A to C, from A to C, from to 2. So move this 1 will be moved from A to C. This is 1. Okay. And then it terminates the function and goes back. So here, this one also is terminated. Okay. And it goes back. And also this one is terminated and it goes back to the caller. Okay. And in the main function, it will be terminated. The main is also terminated here, and the output will be displayed. Okay, as we showed here. And these are the steps of moving 3 disks from A to C by applying rules and by using recursive function method. I hope you got the points here. I hope you practice recursive functions, and I hope everything is clear. That's all for today. Have a nice day.